Hello, participants. I welcome you to the continuation of our last week training on time series forecasting using R. I hope you were able to at least practice some of those assignments. And for some of us who are yet to install R and R Studio, I believe you've done so within the course of the week and try to navigate through the different windows. Um, Today, we want to continue with forecasting methods. Let us not forget that we stop at um, regression-based forecast. So today we take it from there. But before we go straight into the forecasting approaches, we quickly want to look at some preliminaries that always help in case you want to learn the time series forecast yourself. So we're going to start by looking at how to get the data set, because definitely whatever you want to do must be based on availability of data. So we quickly want to look at how to obtain some data sets in case you want to begin to train yourself. Um, when you install R, usually it comes with several data sets, and so many of the packages that we have installed also come with um, some data sets, and some of the data sets are time series. So if you quickly want to look at all the data sets available to you based on packages that you have installed, the procedure is straightforward. Just say data package equals, don't forget this dot packages, then all dot available is equal to true. You run this. Let's run it and see. It's going to give us long lists of all available data sets in all available packages um, that we have, whether in system or user, whatever the nature of the package. It's going to be a very long list, so I think it's taking its time here. So maybe let's wait a little bit. I know it's going to be a very long list because I have so many packages. But maybe peradventure in your own case is not going to be as long as mine, since we just have the packages necessary for the time series that we're considering. Now you can see data sets in package AER. There are so many packages, so it's going to be showing you package by package and so on. You can see long lists, very long lists. So this is one way, and you can now look at some of these packages, some of the data sets, and definitely some of them are time series. So let's go back to our script file. So now you see that's too long for me actually. But now that you are familiar with some time series packages like forecast, like tidy quant, I may want to restrict myself to data that actually came with those specific packages. So if that is your interest, you just say data instead of all available packages, just say data package equals. So you just list maybe two or three of them that you want to get the data set from. So, for instance, I want to look at forecast and tidy quants. Don't forget DC. DC means concatenate. That is, I'm dealing with one more than one package. If it's just one package, you don't need DC. Just say equals to that package, but make sure you put the package in quotes. So now that I'm dealing with more than one, I have forecast and tidy quants. So let me run this. Yeah. Okay, fine. You can now see. So you can see that data set in package forecast. I have Australian monthly gas production, daily money gold prices, half hourly electricity demand, Australian total wine sales, that should be annual, quarterly production of woolen, and so on. So, and in tidy quant, we just have one that is stock prices for the FANG stocks. So now, in case I want to load any of these data sets, let's pick this. Take, for instance, the Australian monthly gas production. If you want to load it, let's come here. So to load it, for instance, since I already know the name, I will just say data. But the starting point is you have to make sure that you load the that's library, because you must first load the package from which you want to get the data. So that's forecasts. Yeah, run. So now to get the data set, I'll just say data. Just remember the name. You can see it's even listing it for me. Gas. Just pay gas. Yeah, simple. So run. So you may wish to look at the data set. You want to look at the data set, just type gas because I know it's monthly data. So run. Yeah, so you can see the data set. I think it ends in 1990, it's 1995. So you can go up, up, up and see the starting point. So it runs from 1956 January up to that should be 1995. See 1995 or 1994 December. That's all right. Okay, so that is how to load it. Very, very simple. And you can auto plot straight away. Auto plot. Because auto plot is in forecast package. Just you see that you get your graph straight away. Run. Yeah. We're supposed to have run it. So what's going on? Okay, yeah, it's running it now. Yeah, fine. So you can see the plot. So we can see that um, gas production is actually on the increase in Australia. And you can see the unequal variance. So as well, you can see a lot of formation here. So you can see the seasonal effect and all sorts of things. That's fine. Yeah, so that is one way. Um, Another way is we have some we have some packages that are actually dedicated to data set alone. It's just provision of data sets and nothing more. A typical example is AgriDat. AgriDat provide data on agricultural experiment data. So you have a lot of information from agricultural experiments that have been carried out. So let's look at that. AgriDat, for instance. This AgriDat. Okay. Let's take, for instance, the data. Anyway, if you want to check the data sets in AgriDat, just I think you can just say data. You say package equals AgriDat. Check the spelling so that we don't make any mistake. AgriDat. So this will give you all the data set. You can see so many of them because you can see that it's not just coming up with few. Like I told you, it's dedicated to data sets generally. So um, it has information on the yield of several series from 1866 up to 2011. Yeah. So, and it's called NAS dot. We have for corn, for sorghum, and so on. So let's try this. This is one of the data sets there. You may want to look at what the data set is all about. Just put asking question here, or you type "ep" and put this in brackets. But I normally prefer to use the asking question. Run. So this will give me information about, well, yeah, so you can see this yield and acre harvested in each state for the major agricultural crops in the US from approximately 1900 to 2011. So the crop includes barley, corn, cotton, hay, rice, sorghum, soybean. You can now see the reason why some of these developed countries keep moving forward. You can see a lot, massive data sets. I don't think that it's this kind of data sets in Nigeria where you can get information from 1900 on any crop. I think I got that of cocoa, but it's a lot of effort on my side because I think I started collecting the data when I visited Crane. So I went to the library. Some of them were scattered inside some kind of files. You see, so that's the data set. So, and you may want to look at the first six observation. That's edge, nas.con, run. So this is the first. This is from 1866. The state acre and yield for corn. If you want to look at, let's say your interest is to look at the last six. For last six is tail anyway. So that's tail. Nas.con. So this is the last six of various states and so on for the corn. So this is a kind of massive data set on corn. And I want to believe that it will have been updated to something like 2021 if you probe into the source of the data set, actually. Yeah. Not only agree that is dedicated to data set, we have another one uh, that's that one is my friend because I think I use that one often actually. Library is ECDAT. ECDAT means econometrics data set. So this is devoted to, for some of us with keen interest or maybe special flair for econometrics. So we use data set from this package because dedicated to econometrics. So let's load the pack the let's load it. Yeah, still loading. Like I told us, anytime you are working and you have this red button here, it's telling you, please wait a little bit for me to finish what I'm trying to do. That's fine. Oh, yeah, just like before, you really want to check out. There's so many packages. Mashaka Polia. Yeah, so many packages there. You can see out so many of them here. Quite plenty of them. That's all right. So so many of them. Yeah. Now let's go back to um a script file. Yeah, one of the data set is CRSP mon. So let's get the data set. That's fine. To really check what the data set is all about, I use my asking question this so that this is monthly. This is monthly return from the CRSP database. So these monthly observations from 1969 to January, that's 1961 January to 1998 December. So, and you can look at it. This is time series containing the return of or General Electric. So IBM is return for IBM, return for Mobi Corporation. So you can see then return for the CRSP value weighted index. So these are various company, so on. So yeah, and you may want to look at these references in order to know where the data has been used. So you want to look at the data set itself. It's a monthly data set. So just CRS mon. You can see it has even daily data CRSPD. Yeah, so for months to run this. Yeah, so you have the data sets. That's if you go up, it's going to start from definitely start from 1969. Just like we observe. Should be 1969 January. Yeah, that's fine. And these are various components. Okay. So that's another way, and you can work with all these time series. So information, and you can use it. You can forecast and so on. Another way to extract data set is uh, there is this WDI package. Very, very useful for extracting World Bank Development Indicator time series data. This is very, very useful. I've been using this for quite a while. Very useful. Take for instance, I need information on inflation for Nigeria from World Bank Development Indicator Database. This is the package, library WDI. Don't forget, you don't have the package, just install. So that you will not be confused in case you run it and it's saying there is no package called WDI. It means you have not installed it. Now, so this is the package. Um, if I need any information on inflation, I will just say WDI search. So I search for it. The essence of searching is for me to get the code, a specific code for what I want. So let me search for inflation. You can search for unemployment, education, depending on what you are looking for, GDP, agricultural, and so on. So this is it. Now, here I have 6 variables. The first one is consumer prices. Now, this is my consumer price index. That is the one I want anyway. But you have another one which is food prices. You have wholesale prices, depending on what you are looking for. So since number one is my interest, I will now go up here to see the indicator. So this is the indicator. So what I want to do about, I need it for Nigeria. So I call the data I want to create INFL. You can call it whichever name of your choice, equals to WDI. Country, I use ISO 3 code, NGA, comma, indicator. So I just copy this indicator, you can see. I just copy it, put it here, comma, start. I want it to start from 1960 because I know several data in WDI start from 1960. So, and I need for as many years as possible. So if you have done that, then just run and obtain your information. Run. So, but this works when you are connected. Don't forget that it's extracting it right from the um, database. So you can see, so this is the inflation from, so let's go up. So you can see from year 2020, this from year 2020, okay, that's 2019, 20, up to 1960s. Yeah, that's fine. Yeah, so that's my data set. And since you're already familiar with how to, you can move this straight away. If I were you, I will move it to Excel straight away by using information from Write Excel. We've done that before, so don't let us waste our time trying to do that. But that's what you can do. Let's try another one. Let's say I have interest in primary school enrollments. I may want to forecast primary school enrollment. In this case, I'm trying to forecast inflation. I may want to forecast primary school enrollment across the country, maybe for the next 5 years, based on historical data from 1960. If that is my wish, then I say W search enrollments. If I do this, let's run this and you see. So for enrollments, I have so many of them. There's almost 44. But like I'm looking for school enrollment primary. So let's look for that. School enrollments primary. You can see all this secondary primary school enrollment total. Yeah, so this school enrollment primary, I'm not. Yeah, this is what I'm looking for. This should be number 12 cross. So if I'm looking for, look at the number 12. So I'm looking at number 12, then I'll have to go up and up and up. Hey, okay. Yeah, I think, no, this is the one I want. School enrollment, primary, gender parity. Because, yeah, it's good to use this one so that we don't really worry about the gender EU, this gender parity index. So let's say I'm interested in this number 3. So I come here, look at, just check number 3. So you can see that is, I think that is the one I used. So that's all right. So you just copy. This is the code. Yeah, copy. So I have my Eduk. You can call it primary, whichever, but I just call it Eduk. WDI country, I pick Nigeria. indicator. This is my indicator, start 1960. Then I get my data set. So let's run it. Run. Yeah. So it's retrieving. That's fine. Okay. So in this case, we don't have information from 1960. So let's see. I think the information starts from 1970. That's good. So you have information from 1970 to 2020. But you see, in this situation, you have some missing data. For instance, we don't have data for 2020, 2019, 2017, 2015. You have some missing data. Maybe in some other training, I'm going to teach you how to input missing data when you are dealing with time series. Because most of the time, this is a problem that you cannot run away from, particularly when you are dealing with daily, monthly data sets most of the time. Now we are dealing with even yearly data, annual data. We are still encountering this problem, but there is a very simple way to go about it. Yeah, there is another way to get your data set, and that is getting data from pen word table. Pen word table contains some macroeconomic data sets, very, very useful. So, and you use what is called PWT10. I think that's the latest. So, install it if you don't have it. So, this is it. The beauty of this is that it's going to give you all the data sets at once. So, this is the data set 10.0. So, run. So, and in this case, I convert it to data frame so that it's going to be so that I can easily export it and extract it from my what is it called? Excel. Simple, very very simple indeed. So let's run this and see. So that's it. So if you want to check maybe the last 6 observations, so this is the last 6 observations, and there's also many of them. So and I sent to you, because if you have not received it, please check very well. A kind of manual, a very simple manual, so that we understand what all this code means. So yeah, so that you can know the meaning of all these codes. I sent it to you, everybody. So that's it. Then you can write it so that you get it in your Excel. That's fine. I already have it, so you are familiar with this process. So now to go straight to our forecasting. Let's start by forecasting daily data. Um, okay, as a reminder, let us get our COVID COVID variable, COVID data. We are familiar with this concept. We did it last week. So let's run it and relax a little bit for the data to load, because now it's going to load up to what happened yesterday. So, and already we have more than 40 MB. I think the other time it's slightly above 40. So now that we have 1 week more, so who knows? Maybe it's going to be going to something close to 50 or thereabouts. So I think we just need to exercise a little patience um, for the data sets to load. It's already out. Okay, that's fine. Um, so while it's loading, let's begin to look at a few other things. So that's fine. So it's even fast. That's great. So now that we have our data set, let's extract Nigeria data on total cases. From February to June 2020. So that's It's just what we've done, so that we obtain. So let's do that one quickly. Yeah, and let us select. Okay, we would need tidy verse. I don't think we have loaded our tidy verse, because if you don't have tidy verse, for sure, percent greater percent will never work. So let's come here. Library, we did that one last week. So tidy verse. All right, that's good. Oh, so which means we already have it somewhere. So now let's get our data set for Nigeria. Um, so we are looking for Nigeria, then less than July data. So rather than select location data and total cases. So let's do that. Run. That's fine. Um, yeah, that's good. You may want to check your data sets as NIGD. So just run it. Yeah, I can see the data sets. Yeah, so it contains the location, the date, the total number of cases for different days, and so on. So to forecast, now we are moving to the actual forecast. To forecast, the starting point is to convert the total cases to time series. And set the frequency to 7, that is on weekly basis. That is a very good way to handle it. So remember that forecast works with TS, that is time series data. So this is converting it. I say TS, my NIG, my interest is the total case. That's why I say dollar total case. Frequency 7, because I'm dealing with daily data. You have done that. Let's okay. Yeah. Where is the information? Because we need to run this thing. Okay, our scripts already miss. Okay, that's good. Looking for my run. So let's run it. Let's come down here. So this where we are. Let's run this. Run. Fine. So now to use naive method, let us not forget naive is based on just the last value. We have uh, we have seen that one when we are dealing with the PowerPoint. So this sits. So let's run it. And we are forecasting for the next 14 weeks. Run. That's fine. Then you want to check your forecast. Definitely this will just give us one value for all the 14 periods. So this just say now if run. So you can see now. So just I know it's going to give us just one value throughout. So you can see for the 14, it's going to be 14. That's all right. Then you can use average method. Average is just mean too. That is the mean of all the data points. So if that's okay, you can also plot this to see the graph. Okay, you can see. Um, just based on the last value there. But for the mean, the mean will come down. It's based on the mean. So that's the average. So for the average, just run it and you will see the difference. You can see the mean. Then based on simple exponential smoothing approach, it's SES, straightforward. So just run it, run. Yeah. Um, Now we have ETS. Let me explain ETS for us. So ETS is a very nice method. ETS mean because since ETS work with these daily, weekly, monthly data sets, where it is expected that you are most likely going to have some kind of seasonality. So this is error. Definitely, you believe we have some error. Components, we have the trend components. The error is the residual component or the random component. Then we have the season, seasonal. So that's the meaning of ETS. So it's and your exponential smoothing could be based on this ETS. So I think we have considered some of these things when we are trying to look at the PowerPoints. So let's for ETS is ETS, so it's straightforward to do. Um, so you try to get the ETS, yeah, to get the model, yeah. So I call it ETS underscore ETS underscore one. So to look at the model, so you can see the model as well as the so you can see the smoothing parameters. So, and this is a typical example of ETS AAN. We have seen what it represents when we are looking at smoothing taxonomy. Yeah, now you can get the summary if that is, if you really want to do that. Yeah. Okay, I think, sorry, should be TF1, not F. Good. Um, Yeah. So this giving you all the details, everything, the smoothing parameter, and showing us the diagnostic test. I mean, sorry, the accuracy test and so on. Yeah. Yeah. Then you can now make your forecast based on this and that one. So that to forecast run. That's fine. Then we have the Oat Linear Method. For your Oat Linear method, is oats. So, and you can also auto plot and get, yeah, you can see this is actually increasing. Then we have the damped trend method. The damped trend method is also oat, but let us not forget because when I'm discussing it's actually based on Oat linear method. But here you just say damped equals to true, and you define your parameters. And you define how many weeks of interest. So this run, yeah, that's fine. Yeah, good. So you can see. And yeah, you can plot everything together. So, but anytime you want to use this auto layer, you must first plot the original time series data, which is our 90 ETS. Then you include all the methods. Yeah, good. Run here so that you have everything together in just one. Okay, sorry, it's complaining we have not run a Riemann. So this thing this is where we stop. Yeah, we can include naive, mean, and sort of things. So ETS, we can just this will work straight away now. Yeah, that's fine. Yeah, good. So you can see that method, old method, naive method. You can just to layer whichever method you want. So that's the procedure. But now the last aspect is, well, I have so many methods, then which methods should I now use for my policy recommendation? So to guide you, then you have to do the accuracy test for all of them and select the one with least root mean square error accuracy test. So just the accuracy maybe start with knife, run. So the root mean square is 303. Yeah, let's try that of accuracy. Many of them. So let's include that of damp F. If you look at that one, you can see this is better because the root mean square error is lower. So you can do that, and definitely you select the one with the lowest root mean square error as the best model, so that you will now use the forecast based on that particular model to make your policy recommendation. Yeah. So that is the approach. It's very simple and clear. So now, since you can generate your data yourself or some other things, I will want us to please practice the first assignment using this approach. And before we now look at details about forecasting using autoregressive integrated moving average, ARIMA. So thank you.